Hi, my name is Park Keun-pyo in HPIC Lab. Today, I will introduce auction-based data transaction in mobile networks, data allocation, design, and performance analysis. First, let me explain the table of contents. First, I will talk about objectives, and then I will explain main contribution, notation, and algorithm. And lastly, I will explain simulations and results and finish the presentation. Objectives. Problem is increasing data demands of mobile users. All MNOs data plan is not run out by the end of a month. The remaining data will not be accumulated to the next month's data plan. On the other hand, when the monthly data has been used out before the end of a month, mobile users have to purchase some extra data with a higher price than monthly plans. The solution is operating the data transaction among the mobile users by turning on the Wi-Fi hotspot function of smartphones. According to a certain rule of contract, rule or contract of data transaction, data owners can sell their unused data to those data requesters at a lower price compared with the market price. There is three main contribution. First, established a basis auction framework for the data transaction system with only one data seller. Designed allocation mechanism can increase the total income of system, and the data transaction efficiency can be also guaranteed. Second, propose multiple data owners network data transaction system. Satisfying data supply and demand at the same time also improve the efficiency of data transaction. Third, design three different data allocation mechanisms. How to sell data in a single day for every data auctioneer in the system. Maximize each auctioneer's income or the entire income of the system. Prediction of the data bidder's movement is optimize the system performance. Notation. There are a lot of notations in this paper, so I will explain it whenever it comes out. First, I will introduce a basic auction mechanism. A data auctioneer is the mobile user with unconsumed and needless mobile data, selling data blocks in each round. A data requesters is the mobile users who have the data requirements, and potential data buyers and give bids for the data. A beginning of a basic auction is data owner starts auction by unlocking hotspot mode. Starting price is V0 to V0 of 1 block. Bid arrivals for the data owner is Poisson distribution with bid arrival rate lambda. Auctioneer decision is after each bid arrives, data owner waits for considering time. If next bid arrives before the end of the considering time, then this considering process is repeated for this new bid. A data transaction procedure is the data transaction will last a service time before starting a new round of data auction by the data owner. Data allocation for single auction transaction, efficiency aware data allocation, EADA. And the data auctioneer anticipates higher efficiency as well as an optimized income. It will necessary to design a data allocation method which can achieve a trade-off between the total income and time cost. C is a total data remain, and gamma d minus d is amount of data to be used by data auctioneer. CD is considering time. So C minus gamma d minus d control increasing speed of the bid acceptation rate with increasing CD. Next is efficiency and request-aware data allocation. The requests from data bidders on these days are hardly met if the bid arrival rate is small, which may also result from that there are not too many data requesters. The equation of ERADA is similar to EADA, but it is different because there is a P2 value. When lambda d is smaller than RD, P2 is exponential RD, lambda d minus RD is smaller than 1. When lambda d is greater than or equal to RD, exponential RD lambda d minus RD is equal to 1. So ERADA's the equation of ERADA is same to EADA if when lambda d is greater than or equal to RD. Next is mobility model. Arrivals from the outside of the system is data requesters arrive into auction I from the outside of the network according to Poisson process with arrival rate is lambda I 0. Departure from the ith auction. Bidder providing the current highest price for the data cannot leave auction I until that the next bid arrives or the next data seller decides to accept its bid. The rate of departure from auction I is I and I Vj. Departure from auction I to the outside of the system denotes PID as the probability that the data bidders in auction I leave the entire networked transaction system. Departure from auction I to auction K. Data requesters transfer among different auctions according to the amount of remaining data to be sold in these auctions. Probability from auction K to auction I with PKI. Next is data allocation for networked data transaction. Non-cooperative distributed data allocation (NDDA). NI at time slot M, data requesters in auction I at time slot M, and the amount of data to sold is ZIM. Then the expected income of data auctioneer is below equation. ZIM EINI M. ZIM is sigma J1 to HI JPAI J NIM. A lower bound Z mean ensures that the data owner with the most amount of data to sold on the current day can sold out all of the data before time slot M or M ends. Next is prediction-based cooperative distributed data allocation (PCDDA). The expected income of the current time slot can be predicted for a fixed number of data requesters. Potential average income of the next time slot can also be predicted by predicting mobility trend of data requesters. So data owners can make better decisions on how much data to sell in the current time slot for maximizing the total income of M time slots. Assume that every data auctioneer is selfish and intends to maximize its own total expected income of the M time slots. Income maximization problem for each data auctioneer I at time slot M is below equation. At the beginning of every time slot, each data owner publishes the rest amount of its data. Second, observe the number of data requesters in each auction. Third, solve the optimization problem to determine how much data to be sold in the current time slot. Next is prediction-based centralized data allocation, PCDA. According to PCDDA, if every data auctioneer solves the optimization problem locally to maximize its own expected income instead of central process, the optimal solution for each data auctioneer cannot ensure sigma I jet n jet im is smaller or equal to jet ch is always certified. PCDA maximize the income of all data auctioneers by Data Fusion Center, which operates the PCDA and determine how much data to be sold for every data seller in each time slot. PCDA tends to allocate more amounts of data to be sold to the data owners with more current expected income in a single round of a data auction, which can increase the efficiency of the networked data transaction system. Next is simulation results. For case 1, the bid acceptance rate is always lower than the bid arrival rate for 10 days. Similar to the result in figure 3, EADA and ERADA get the same amount of modified RC and allocated data every day. If you look at E in figure 4, the original data that does not adjust RC tends to be assigned to the start date. So the data after that is not being satisfied at all. So if you shorten the considering time from 1 to 5 days, the data allocation for 10 days is more balanced as shown in figure 4a. In the case of case 2, it is opposite situation of case 1. If you look at B in figure 4, you can see the trade-off for EADA time and income. ERADA is able to achieve both the best balance and optimized income among the three methods. In case 3, ERADA has the highest gross income and the best performance due to its adaptation to arrival rate. But the time cost is higher than that of EADA, but in most cases, the efficiency of consulting time is higher than that of original. In the case 4, as I mentioned before, ERADA has a worse considering time than original. If you look at H, all the data in original are allocated on the last 4 days, but the total time cost is very small compared to EADA or ERADA. So the average income increases. Table 3 shows that your ADA has a small total income, but the average income per unit time is higher than the income obtained without considering time modification. Um, Next, figure 6 shows that PCDDA, which uses predictive information and maximizes income during the entire auction, gets a higher total income than NDDA. And when you apply PCDA, which seeks to maximize the total income, some auctioneers get a higher total income. NDDA, which does not use predictive information, maximize current income and as a result, it can be seen that NDDA has the highest income at beginning and decrease gradually. Thank you for listening.